Recording now, this is lesson 4.3, an introduction to exponents. Before watching the video, please make sure that you have the 4.3a introduction to exponents worksheet, along with a pencil, some different colored pens, and perhaps a highlighter. So if you need to pause the recording to get those items, please do so now. So I'm just going to continue, and hopefully at this point you've been able to watch the Brain Pop video on exponents. Now it gave you a pretty big overview on exponents and how they're used in real life contexts. Now the emphasis this year will only be on the use of positive exponents. And if you caught the explanation in the video, positive exponents are primarily used to describe big quantities of things in a compact way. So one example would be distances in space, the number of red blood cells in the human body, or the exponential growth of an animal population. So what we're going to do is we're going to backtrack and look at the specific math behind how exponent form is used. What I'd like you to do is focus on number 1 here on the sheet. So it says to come up with all of the different ways you can write the number 64 using multiplication, and write them in the space below. Some things to think about, perhaps think of all of the different arrays of 64 or come up with different factor trees. And if you want to pause it now and just come up with all those different ways and then resume the recording when you're finished, I encourage you to do so now. So I'm going to continue. So I'm going to think of all the different ways we can get 64 using multiplication. So I'm going to go 1 times 64. I'm not going to complete my factor tree. Another option would be I'm going up by 2. I know it's divisible by 2. I can go 2 and 32. Another possibility, I know it's not divisible by 3. It's divisible by 4. I can get 4 and 16. And then the other option I believe would be 8 times 8 would give me 64. Now what I'm going to do is I'm only going to focus on these last 3 options here. So notice that one option we have here is 8 times 8, which is repeated multiplication. And we're going to go after the examples that give us repeated multiplication. 64, okay. So I know that 4 times 16 will give me 64. Remember, a factor tree is built on multiplication, so the two numbers the two numbers below the top number are two numbers multiplied to give you that number. I know 16 I can get by going 4 times 4. Now, I'm highlighting 4 times 4, which is 16 times 4, and this example will also give us 64. I'm also going to look at 2 times 32 here. Now, if you remember with how factor trees work, I know that 2 is a prime number, so I'm going to carry it down on a single branch. Now I think to myself, what times what, or what two numbers multiplied together will give me 32? Well, I know that 8 times 4 will give me 32 as an option. I'm going to keep going on this tree until I get all prime numbers. I want the prime factorization of 64. I'm going to carry 2 again on a single branch because it's prime. I know that 8 is still composite because it can be broken down into 4 times 2. I look at this other 4 here. I know it's still composite because you can break it down into 2 times 2. Now, we're not quite done yet because we want to still break down that 4. We're going to break down all the 2's on a single branch because they are prime. And the 4 we know is still composite. It breaks down into 2 times 2. If we look at the bottom of this factor tree now for 64, we know that we have all prime numbers. And again, another form of repeated multiplication, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Notice that we only looked at the examples that gave us the repeated multiplication of 64. So that's our first vocabulary to look at, or vocabulary term to look at. So if we look at the repeated multiplication, and you can jot this down here, and again, only focusing on 64, we know that one example, 64 can give us, 8 times 8 can give us 64. So that's example 1. The second example, again, only repeated multiplication. 4 times 4 is 16, right? Times 4 will give us 64. So we know that also gives us 64. We look at the third example, which is the longest example, but also gives us a repeated multiplication to get to 64. 2 times 2, which is 4, right? Times 2, which is 8. Times 2, which is 16. Times 2, which is 32. Times 2, sorry, make that bigger. Times 2, which is 64. I just make sure I have the right number of sixes. 1, 2, 3, 4, 5, 6. That also is the repeated multiplication of 64. It's when we multiply a number by itself. Now, what exponent form does is it makes it become a shortcut way of writing all of these down. Because suppose I asked you, if I were to continue the 2 example, I asked you to calculate 2 times 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 2. Now it can get quite cumbersome and a bit of a pain to write down all these 2's. So there is a shorter way of writing this. Now, I'm going to demonstrate what I mean by that. I'm just going to erase this. Okay, so if we look at 8 times 8, which gives us 64, another way of looking at it, and I'm just going to write it in, let's write it in purple here. Another way of looking at it is, if 8 is a number being multiplied, I'm multiplying it twice. So it's 8 to the power of 2. I look at the second example. Well, 4 is the number being multiplied, right? 4 times 4 times 4 is 16. How many times are we multiplying 4? We're multiplying it 3 times. So another way of saying it is 4 to the power of 3, which equals 64. Finally, the bottom example. Okay, what is the number being multiplied? The number being multiplied is 2. How many times are we multiplying 2? Well, we're simply counting the number of 2's. 1, 2, 3, 4, 5, 6. 64 also equals 2 to the power of 6. So perhaps by now you've figured out the pattern in which we derive exponent form from expanded form. Let's look further at this vocabulary here. The base of the exponent form or exponential form represents the number being multiplied. It's whatever the repeated factor is. So in the first example, 8 was the base because it's a number being multiplied. In the second example, 4 is the base because that's the number being multiplied. And then the third example, 2 is the base because it's a number being multiplied. Think of base as being something big, like a bass instrument. The instrument, the bass, is quite big. Think of the bass as being really loud, booming music from the car. When you hear somebody driving down the street with the bass really pumping from the car. So think of the bass as being loud and big. So the base is always written larger than the exponent. And that's how you can remember the difference between the base and the exponent. The exponent, on the other hand, is written pretty small, and usually when you're in a Google Doc, you choose superscript. So it's significantly smaller than the base. It represents how many times the base is being multiplied. And we often say to the power of, right? So again, in the first example here, 8 times 8, 2 is the 2 is the exponent because 8 is being multiplied twice. In the second example, 3 is the exponent because 4 is being multiplied 3 times. 3 is the exponent because 4 is being multiplied 3 times. I hope I said that right. And then finally, in the last example, 6 is the exponent because 2, the base, is being multiplied 6 times. Now, the third vocabulary, or third and fourth vocabulary that's listed there is something called squared or cubed. So there's special ways you can say 4 to the power of 2. It can mean 4 squared. 8 to the power of 3 can also mean 8 cubed. And it has to do with how we calculate area, which is measured in square centimeters or meters. And then we measure volume in terms of cubic units. So those are other ways you can say it. So just to further illustrate this as an example, so for example, you could have, let's say, 5 to the power of 3. So 5 represents the base because it's the number being multiplied. 3 is the exponent because it represents how many times 5 is being multiplied by. Now, you can also say 5 to the power of 3 or 5 cubed because it's to the power of 3. In expanded form, we would have 5 times 5 times 5. We would have 5 times 5 times 5. And then, it would equal 5 times 5, which is 25, times 5, which would give you 125. So the answer to 5 to the power of 3 would give you 125. Now, I noticed that you may have a different version of this chart down below that we're going to fill out. The exponent form and written form is actually in the wrong spot on my chart, but it is in the right spot in your chart. So I'm just going to fix it here. The expanded form should be in the middle, like what you have on your form. So I'm just going to rewrite everything here. 2 times 2 times 2 times 1, 2, 3, 4, 5. And then finally 9 times 9 times 9. So if you would have figured out by now, expanded form means you're just expanding it. You're doing the repeated multiplication to represent the exponent form. The exponent form for the first example, 8 times 8, would be 8 to the power of 2. It's similar to the example up above there. So the written form would be 8 to the power of 2. So jot this down. Okay. The standard form for this, so you're simply calculating what it is in expanded form, would give you 64. Okay. Now, a really common mistake people make, and I'm just going to write it up in red here, is if you see 8 to the power of 2 or 8 squares, some people will automatically think it's 16, but it's not. You are not doing 8 times 2. You are doing 8 times 8. So whenever you see exponent form, you're multiplying the base by itself, however many times the exponent is. The next example here, we'll go back to purple. The next example here, you have 2 times 2 times 2 times 2 times 2. Okay, so the exponent form, I want you to figure out what the exponent form and the written form is for this, and then the standard form. So I invite you to pause the recording now and figure out the last 2 examples and then resume the recording when you're finished. I am going to continue now. So I know for the second example, our base is 2 because that's the number being multiplied. Remember, the exponent represents the number of times the base is being multiplied by, and that's 3. No, sorry, why did I say that's 3? That's 5. So what I mean to say is that is 2 to the power of 5. Now, what I just noticed here is that another way of saying 8 to the power of 2 is also 8 squared. I forgot to write that down earlier. Now, to calculate the standard form, we know that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the standard form is 32. Last example here, we know that the number being multiplied is 9, so that represents our base. The number of times it's being multiplied by is 3. So remember, there are 2 ways to say this because it's to the power of 3. So for example, you could have 9 to the power of 3, or you could have 9 cubed. Those are 2 ways to have it in written form. If we were to calculate this, we would go 9 times 9, which is 81, times 9, which I believe is 729. So the standard form is 729 for 9 to the power of 3. 2 more things that I want to just go over before we end the video. If you go to your scientific calculator, and I'm just going to pull up a different screen here for a second. Now I'm just going to zoom in on 2 important buttons. The first important button that will become very important to you in a later unit, in a later lesson, will be x to the power of 2. That's x squared, and that'll be really crucial when we do area of a circle next. The other button on your calculator looks like y to the power of x. So that you can use for any exponent and any exponent form that you want to calculate on your calculator. X squared is only for any any base raised to the power of 2. So I'll jot those down on our notes here. So on the calculator, just do it in yellow here. On the calculator here, things that you want to keep note of, and I'll do this in maybe blue here. On the calculator, you want to look for the y to the power of x button along with x squared. To summarize what we've been talking about, we have exponent form. Make sure that you familiarize yourself with the different parts of exponent form and how it relates to the idea of repeated multiplication. Essentially, exponent form is a short form of repeated multiplication. So it's handy, it's a shortcut that can be used to express really large quantities. Understand the relationship between exponent form, written form, expanded form, and standard form. It goes back to when we were looking at place value with large numbers and decimal numbers. So it's essentially the same thing, but understand that you're always multiplying the base by a number of times. It's a repeated factor. It is not, for example, we used 8 to the power of 2 does not equal 16. It's not 8 times 2, it equals 8 times 8. So again, base and exponent.